Hello and welcome to Maths with El Profelo. We've been doing some work with Wilson's theorem and proving some congruences using Wilson's theorem. Our next problem is going to be another proof, and we're going to say that n is going to be an integer greater than 1. And we're going to prove that n is a prime number if and only if n minus 2 factorial is equivalent to 1 mod n. So how can we do this? Well, first, if we have an if and only if, we're going to have to show that if this is true, then the right side follows as a consequence, and that if the right side is true, then the left side follows as a consequence. Okay. So let us do the following. Right? And we're going to show the piece. So if n minus 1 factorial is equivalent to negative 1 mod n, okay, then n is prime by Wilson's theorem. Okay, and that's our information right up here, right? That if n is an integer with n greater than 1 and n minus 1 factorial is equivalent to negative 1 mod n, then n is prime. So we're just repeating that statement. Okay, so what do we know? N minus 1 factorial is equal to n minus 1 times n minus 2 factorial, which is equivalent to negative 1 mod n. Okay, now what do we know? All right, n minus 1 is equivalent to negative 1 mod n, so therefore n minus 1 factorial is equivalent to negative 1 times n minus 2 factorial mod n, right? Which implies that n minus 2 factorial is equivalent to 1 mod n. Because we know n minus 1 factorial has to be negative 1, so this n minus 2 factorial has to be positive 1. So that's one of our directions, right? That we've shown now that n minus 2 factorial is going to be equivalent to 1 mod n, right? Going in the right direction. Okay. Next, we can do the following. If, right, n minus 2 factorial is equivalent to 1 mod n. Okay, so so if n minus 2 factorial is equivalent to 1 mod n, then n minus 1 times n minus 2 factorial is equivalent to n minus 1 times 1 mod n. Okay, which would then mean that or first we'll say, now we know that n minus 1 is equivalent to negative 1 mod n. So therefore, n minus 1 factorial is equivalent to negative 1 mod n from this piece. Okay, which implies that n is prime, by Wilson's theorem. Okay, so therefore, or hence, right, hence, if n is a prime number, right, or rather, hence n is a prime number if and only if n minus 2 factorial is equivalent to 1 mod n, where n is an integer greater than 1. Okay. Now I should clarify an earlier statement that I made here. When we're proving if and only if, right, and I wrote these arrows in the wrong locations, right, when we're proving if and only if, I need to prove, right, that if n is prime, the following is a consequence. But I also need to prove that if n minus 2 factorial is true, then the consequence is that n is prime, right? That I have to prove both sides of the if and only if, and that's what we did here, right? So for this first one, right, we could say, hey, we're going to have this be true where n is a prime number. All right, so n is a prime number, this is going to be true, and this part would be the part of the proof going in the other direction. We're saying, hey, so if the left side is true, and then if the right side is true, going through and doing the work. And of course, this was a proof, so we end with our QED, quod erat demonstratum, and we've proven that n is a prime number if and only if n minus 2 factorial is equivalent to 1 mod n. Okay? Thanks for taking the time to be with us here at Maths with El Profe Lo. As always, if you have questions, please do reach out.